Okay, so for question 5, we're talking about solubility products. You're given a table of data and told to predict which one will have the most precipitate for 5A. Now, I think the key bit of information is that the volume of calcium nitrate is the concentration of calcium nitrate is twice the concentration of sodium carbonate, and that's important information. Now, when you do the balanced ionic equation in the first step, you find that the ratio of reaction is 1 to 1. So what that means is that whichever concentration or whichever reagent has the smallest concentration, that is going to be the limiting reagent. So you're only going to make the same moles of product as the moles of your smallest concentration. And tube 4 gives us 4 millimolars, or 4 times 10 to the minus 3 moles of calcium nitrate and 4 times 10 to the minus 3 sodium carbonate. And that will all react together to form precipitate. Whereas in all of the other substances, your limiting reagent is smaller than 4 times 10 to the minus 3 moles. Therefore, tube 4 will produce a higher amount of precipitation than the others. Okay, so the way to express that answer would be ratio of reaction is 1 to 1. Tube 4 has the most moles of both substances compared to the other tubes, and you can give the calculation. That will be very helpful for you. Therefore, it will make the most precipitate. Done. Now, for 5C, this is kind of sad for me that we got this wrong. The KSP for calcium carbonate is 8.7 times 10 to the minus 9. Work out the molar solubility. Well, two main concepts. The molar solubility is equal to X because the ratio of the ions in this precipitate is 1 to 1. Your KSP expression is here. 8.7 times 10 to the minus 9 equals concentration of Ca times concentration of carbonate. As a result, you put X and X because the change in the reaction is that, right? X amount of Ca ions, X amount of carbonate, X amount of calcium carbonate. And you get X squared equals 8.7 times 10 to the minus 9. Then square root both sides to get X. A lot of people got that wrong, which was sad. Finally, for 5C2, if an excess of sodium carbonate remains in the solution, will the solubility of calcium carbonate be affected? You've got an ion, which is the same as the ion in your precipitate. It's the common ion effect. I think maybe 2 people wrote the words common ion effect. But you have a substance which is changing the concentration of carbonate. And remember, common ion effect normally works as you're increasing the concentration of one of these ions. Therefore, the solubility of this whole thing will go down because you are adding more of the dissolved substance. Your equilibrium will make less of the dissolved substance. Okay? So that's for your